let us start our class today. So till question number 3 we have done, right? So today question number 4. In figure 6.19, so see the diagram. In this diagram what is given? DE is parallel to AC and DF is parallel to what? AE. Prove that BF by FE is equal to what? BE by AC. So let me draw the diagram at first. Question number 4. So it is given as ABC is the triangle. Okay. So this is the triangle A. Triangle. Then what is given? DE is parallel to AC. So there is one DE. Okay. This is DE. So this DE is parallel to what? AC. And if I join this one, so with this what will be parallel? DF will be parallel, right? So this is the diagram. So what is given in this question? In figure 6.19, DE is parallel to AC. So write in the given part. This is easier than question number 3. Okay, solution. So what is given? DE parallel to AC. So given DE is parallel to AC and next what is given? DF parallel to AE. DF is parallel to AE. This is given, right? Prove that BF by FE is equal to BE by EC. So prove that. That means to prove what we have to prove. To prove BF by FE, BF by FE is equal to BE by EC. BE by EC. So start the proof. PROOF. Okay, let us start the proof. So again process same. Use the given part and after that find the triangle and use the Thales theorem. Okay, Thales theorem only we have to use. So first is DE parallel to AC. So in which triangle DE is parallel to AC? There are a lot of triangles over here. Okay, so in which triangle DE is parallel to AC? That we have to find it first. So this is DE, right? This is DE and this is parallel to AC. So AC is the larger part. So that means AC will definitely come in the triangle. So what will be the triangle? See, DE parallel to AC. The triangle will be A, B and C. In this triangle only DE is parallel to AC. If someone is finding difficult to understand which triangle it will be, so let me simplify the diagram for you. This is DE. So this is DE, right? This is DE. Then AC. DE is parallel to what? AC. This is AC. AC is the larger one. This is DE. And this is what? This is AC. Right? So join the triangle. Over here is what? B. So what is the triangle? The triangle is ABC. Understood? This will be the triangle. Okay. ABC means the complete triangle. The complete larger triangle is what? This is the triangle ABC. Okay, so now see, now write proof in triangle what? In which triangle? In triangle ABC. In triangle ABC, since DE is parallel to AC, so therefore what we will get? We will get what? By any way you can start. We will get BD. In question what is there? Okay, we will get BD by DA. From here only I am starting. You can start by here also AD by BD. Okay, like this also you can start. But let me start from here. BD by DA. So BD by DA will be equal to what? I have gone like that. Okay, BD by DA. This will be equal to what? BE by EC. Right? Like this I have gone BD by DA. So it will be like that. BE by EC. BE by what? EC. So you give the reason by what? By Thales theorem. Okay, by Thales theorem. Done. Next, you give this as equation 1. Okay, this is equation 1. Again in triangle. Now for this parallel, in which triangle DF is parallel to AE? So you see, this is DF, the smaller one, and this is AE, the larger one. So what will be the triangle? So larger one will definitely come in the triangle AE. And how? This will be the triangle ABE. Try to understand. This is DF, okay? This is DF, and this is AE. This is AE, the larger one. So the triangle will be how? Triangle will be like that. Over here is B. So the triangle will be what? ABE. Understood? Try to find the triangle directly from this diagram. Okay, no need to draw this like this. It is better if you find directly from this diagram only. So in triangle, what will be the triangle? ABE. ABE, right? In triangle ABE, since DF is parallel to AE, so therefore what we will get? Again the ratio, like this only I will start. BD by DA, okay? BD by DA will be equal to BF by FE, or I can say that BF by FE. Now don't make mistake, okay? Don't write BF by FC. The triangle is still this much only, okay? That's why it is important to find the triangle at first. The triangle is ABE. So this part not there now, okay? This part is not there. So BF by FE. BD by DA is equal to BF by FE. BF by FE. Again I can write over here what? By Thales theorem. This is what? Equation 2. Understood? We have got both equation 1 and 2. Same like question number 3, we have proceeded using both the given part. We have written what? We have written two equations, okay? Equation 1 and 2. Again we will do similarly what? From 1 and 2. What is common we will see, okay? So see, in equation 1 there is BD by DA, and in equation 2 also there is what? BD by DA. That means left part are same. So if two parts are matching, then the other two part will also what? It will match. So I can write from 1 and 2. From 1 and 2 what will I get? See, these two part are matching. If these two part are matching, then the other two part will also match. That is, I can say BE by EC will be equal to BF by what? FE. Now what it is given to prove, okay? I have removed that part. In the question what it is given to prove? BF by FE, that is BF by FE is equal to BE by EC. So we have got the answer. Simply you write this one at first, that is BF, this you write at first, by FE will be equal to BE by EC, hence proved. Understood? So this is how, this is easier than question number 3. No plus 1 minus 1. Directly we have got the answer by equation 1 and 2. So use the Thales theorem. Find the triangle from this diagram. Okay, in which triangle what is parallel? Understood? Let us see question number 5. Question number 5. In figure 6.20, so let me draw the diagram at first. What is the diagram? Then it is ED. So this is P, this is Q, this is R, and this is E, D, F, and O. So over here also the question pattern is same. Only you have to find the triangle, in which triangle, but which parallel is in which triangle. Okay, you have to find the triangle only, and then use the Thales theorem. So what is given in this question? Question number 5. What is given? In figure 6.20, DE is parallel to OQ. DE is parallel to what? OQ. Okay, DE is parallel to OQ. And DF is parallel to OR. And what? DF is parallel to OR. Show that EF is parallel to QR. Show that EF is parallel to QR means to show what? We have to show what? EF is parallel to QR. EF is parallel to QR means this time we have to show parallel, not any proportionality. Okay, so we have to use inverse of basic proportionality theorem or inverse or converse of Thales theorem. Understood? Since we have to prove this time parallel part. Okay, so again same thing, we will use the given part, we will get some equation, then we will use the converse part and we will get the answer. The process will remain same. So start proof. Okay, proof. What is the first given part? DE is parallel to what? OQ. DE is parallel to OQ. Find the triangle. This is DE. Okay, I am not going to draw any separate diagram. Okay, this time try to find in this diagram only. This is DE and this is OQ. So OQ is the longer side. Okay, DE is parallel to OQ. Which is longer, DE or OQ? OQ is longer. So OQ will stay in the triangle. OQ will be a part of the triangle, okay, or a side of that triangle. You need another one point. What will be the another one point? This is OQ. Which will be the triangle? You see, this is DE. Other point will be P only. So the triangle is what? P, O, Q. OQ is the longer side compared to DE. So OQ will be a side of that triangle. You just need another one point. In a triangle there are 3 points. So O and Q are 2 points. What is the one point? Just you find the common point. The common point is what? P. So what is the triangle? The triangle is POQ. So I will write in triangle POQ, since DE is parallel to OQ. So therefore by Thales theorem, what will I get? Right. Okay. This is DE is parallel to OQ. Okay. So I will write PE by EQ. I will write PE by EQ, right? PE by EQ will be equal to what? See, this is the parallel, right? ED is parallel to QO. This is the one side. So PE by EQ. Another side is what? ED. This is the another side, right? So PD will be what? PD by DO. Understood? See, DE is parallel to OQ. Okay. DE is parallel to OQ. So DE, over here it is intersecting, right? So one will be what? PE by EQ. DE, over this D point also it is intersecting over here. So another will be what? PD by DO. Understood? You have to see where is this parallel touching. Where is this parallel touching? Okay, so one part will be this part, another part will be this part. Again one part will be this part, another part will be this part. So it is touching in this E point. So one will be PE by EQ. Again it is touching in D point. So it will become what? PD by DO. Okay. Look at the diagram properly. Okay. You will get the answer. You might find it little bit difficulty. But look at the diagram properly. This is the parallel. Say for the last time I am drawing once again a separate diagram. This is ED. This is ED. And this is what? The longer side OQ. O and Q. So if I draw the triangle like that, so how it will be? So you see it is how? It will be like this. Okay, forget about it. It will become PE by what? EQ, and it will become what? PD by DO. Understood? Try to find it over here only. PE by EQ will be what? PD by DO. Okay, this is DO. PD by what? DO. So over you write by Thales theorem. Clear? Now give this as what? Same way. Give this as equation 1. Again we will use this parallel. Okay. Again in triangle. In which triangle? DF parallel to OR. This is DF. DF parallel to OR. So OR is the longer side. Among DF and OR is the what? Longer side. So OR will be a side of the triangle. So what will be the another part? This will be the triangle. What? POR. in triangle POR, since DF is parallel to OR, since DF is parallel to OR, so therefore by Thales theorem what we will get? Again PDF na? Where is this intersecting point? At D. Okay, DF, the intersecting points are what? D and F. So PD by DO, PD by DO will be equal to what? Another intersecting point is what? F. So it will become PF by FR, PF by FR. Done. Same reason by Thales theorem. Equation 2. Now again same process from 1 and 2. You see what is common in from 1 and 2. What is common in from 1 and 2? Okay. So from 1 and what? 2. So what is common in 1 and 2? So you see in 1 also there is what? PD by DO. In 1 what is there? PD by DO. And in equation 2 also there is PD by DO. Because this PD by DO is exactly the common side of both the triangles. Okay. So simply PD by DO is over here also and PD by DO is over here also. So PD by DO and PD by DO is same. So then what will be equal? From 1 and 2, PE by EQ, PE by EQ will be equal to what? PF by what? FR. PE by EQ will be equal to what? PF by FR. Now what is given to prove? We are given to prove what? EF is parallel to what? I think QR, right? This is what we have to prove. EF parallel to QR. Now from 1 and 2 we have got this thing. Now we have to apply the converse theorem. Okay. So see, when this EF will be parallel to QR, suppose EF is parallel to QR, then what will happen? So this will happen. EF is parallel to QR. So QR is the longest side or not? QR is the longer side compared to EF. So QR is a part of the triangle. So the triangle will be what? Like this. The PQR is the triangle. So then what will be the ratio? So you will say the ratio will be PE by EQ will be equal to PF by FR or not? So let us see what we have got. We have got PE by EQ is equal to what? Is equal to PF by FR. That means we have got the ratio. So therefore we can write what? EF is parallel to what? QR. If the ratio is equal, then the line will be parallel. By what? By converse of what? Of Thales theorem. By converse of Thales theorem. So hence proved. So almost same, only one more line you have to write, by converse of Thales theorem. If you have to prove the parallel part, then a converse theorem will come for sure. Understood? So you have to prove this part. When this part will come? If PE by EQ will be equal to PF by FR, and we have got exactly the same thing, PE by EQ will be equal to PF by FR. So therefore EF is parallel to QR by converse of what? Basic proportionality theorem or Thales theorem. So you see all the questions, question number 3, 4, 5 are exactly same. Question number 6 also is exactly same. The technique is exactly same. Use the given, means the Thales theorem part, then you combine them from 1 and 2, and then you will get the answer. Only in question number 3 we have to do +1 in both the side. Okay. So other questions are actually much more easier than question number 3. Let us see question number 6 now. What is question number 6? Okay. In figure 6.21, so let me draw the diagram. Bigger triangle. PQ R, this is the bigger triangle, and there is one what? A, over here is A, B, C and O. So write the given part, what is given in this question, question number 6. Solution. What is given? In figure 6.21, ABC are points on OP, OQ and OR. Okay, ABC are points on what? OP, OQ and OR. A is on the side OP, B is on the side OQ and C point is on the side what? OR. Okay, this one we have already drawn respectively, such that this is the given part. AB parallel to PQ. So given, what we will write? AB is parallel to what? PQ, and what? Another AC is parallel to what? PR. To show same like question number 5 only, you have to show parallel, that is BC parallel to QR, means at last converse of Thales theorem will be applied. Okay, BC parallel to QR. So start the proof. Let us first take this one, AB parallel to PQ. In which triangle? AB parallel to PQ. Which is the longer one? PQ is the longer side, right? So PQ is a part of this triangle. Now just combine this PQ. This is P, this is Q. Okay, this will come. Don't go like that. Don't go like that. You have to touch this point A and B also. Okay, so don't go like that. Say don't go like that. This is not the triangle. Okay, you have to see AB, na. So you have to touch that point A and B also. So what will be the triangle? So come like that, touching A and B. So the triangle will be what? This is the another point O. Right. So what is the triangle? In triangle OPQ. Understood? What is the triangle? OPQ. Understood how you have to go? AB parallel to PQ. AB is the shorter side, PQ is the longer side. So you take the longer side, and by touching this A and B, because AB is parallel to PQ, find the another point. So you have to come like this, O. Don't go like that, okay? If you go like that, you will not touch A and B. You have to touch A and B, okay? So you have to go like this, by touching B, and over here by touching what? A. So O is the intersecting point. So the triangle is what? In triangle OPQ. In triangle OPQ, since AB is parallel to PQ, so therefore by Thales theorem, what will I get? I can say, from any side you can say from this side we will say this time, PA by AO. Okay, PA by AO will be equal to, so you see AB is parallel to PQ, right? AB, A is the intersecting point. Okay, so P to A, then A to O. Understood? If this is the triangle, so from here to here, then from here to again here, from this point to this intersecting point, from this intersecting point to again over here, like that. Okay, so from P to A means PA by A to O, AO, PA by AO, or you can write like that also, OA by AP, from O to A and then A to P, OA by AP, same thing, it will be the reciprocal of that one. Anyway you can write, but the most important is what? If you have started from here, PA, if I have started like that, PA by AO, then over here also will be what? QB by BO. Understood? This should be same. You cannot write now OB by BQ. If you write OB by BQ, then over here also it have to be what? OA by AP. This you keep in mind. Okay, the direction of it will be same. So if I have written PA by AO, then another one I will start from where? QB by BO. QB by what? BO. Done. Next is what? Okay, you write this one by Thales theorem. By Thales theorem. Same process, give this one as equation 1. Again you write, take the another parallel in triangle what? AC parallel to PR. Where is this AC? This is the AC. Where is this PR? PR. So PR is the longest side. So find the another point. Okay, what? AC. So you have to touch the point what? A and C. AC is the shorter side, PR is the longer side. So PR, you take P and R, and by touching A and C, you find the another point. Take the longer side, P and R, and by touching the other point, what, A and C, right? A and C. So by touching A and C, you will get what is the triangle O. The triangle is what? OPR. This is the triangle OPR. Over here, what you will write? Since again AC is parallel to what? PR. So therefore, by Thales theorem, what I will get? I can say again. See, PR, na? So from P, let me start. And AC is the parallel, right? So PA by AO will be equal to, so PR, na? I have started from the point P, okay? PA by AO. Now another one was what? PR. So I will start from R. RC by CO. Understood? RC by CO. PR. First start from P, and what is there? AC. So come to A. From P, A to O. Another point was R. So from R come to C, then C to O. So that will be what? RC by CO. Okay, CO. So you write by Thales theorem. Understanding the triangle is the most important thing. Okay, if you can understand the triangle, you will get the idea. Understood? So this is equation 1 and 2. Same process from 1 and 2. I can clearly see that PA by AO. This part is matching. So I will write now from 1 and 2. From 1 and 2, what will I get? I will get this. These are exactly same. PA by AO is equal to PA by AO. So from 1 and 2, what will be equal? I can write QB by BO will be equal to RC by CO. Done. Now the converse part we will apply and we will get the answer. So what will happen if this is proportional? You see, QB by BO, check. QB, this one, okay, QB, this portion QB by what? BO. This is BO. QB by BO, okay, and what? RC by CO. This is RC. This is RC by what? CO, and this is what? CO. So if this is proportional, then what we will get? We will get BC parallel to what? QR. We will get BC parallel to what? QR, right? Because if in this triangle QOR, if BC was parallel to QR, then by basic proportionality theorem, what we will get? We will get QB by BO will be equal to RC by CR. Same thing we have got here. Now if some of you are thinking that no, if BC was parallel to QR, then I will get OB by BQ will be equal to OC by CR. This one I will get. OB by BQ is OC by CR. This I should get. So these are same thing. Only the fact is what? Reciprocal. You see, OB is over here in the up. OB is in the below. BQ is in the below. BQ is in the up. OC is in the up. OC is in the below. CR is up. CR is below. So the most important thing is the direction. You can start from here also. You can start from here also. If you start from here, OB by BQ, then you have to start like this. OC by, you have to end like this. OC by CR. And if you start like this, QB by BO, then you have to end how? RC by CO. So we have got in this way, in the reciprocal way. Same thing. So in result, what we can write? Therefore our BC will be parallel to what? QR. And you can write over here what? By, oh sorry, not by Thales theorem, by converse of Thales theorem. Understood? By converse of Thales theorem. Okay. From the proportional, when you get the parallel, that is converse of the Thales theorem. This theorem I will prove at the end of this exercise. Okay. Theorem 6 point, I think so 2, that one. 6.1 we have done the Thales theorem. Converse one we will do after completing this exercise. Okay. By converse of Thales theorem. So hence proved. Finish. So all the questions are quite similar, right? Only what is difference? The diagram. Understand the diagram, understand the triangle. Okay, how this proportional is coming. So that's all for today's class. In the next class, hopefully this chapter might finish. If not finish, then in one more video. Okay. So that's all for today's class. Thank you.